All right, so we just worked on creating a rule for the product of two functions and trying to take the derivative. Next, we're going to work on finding derivatives of quotients. So you might remember that quotients are set up as division problems. So similarly to a product rule, quotients have their own special rule for how we take their derivative. It's not just as easy as taking the derivative of the top and the bottom. We got to do a little more work. It's calculus, but we can handle it. So I'm going to use t and b to denote a top function and a bottom function. So if I want to take the derivative, it's going to be bottom times the derivative of the top, that's what that prime is for, minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, so there's another little way to remember it. This is even a little bit different than how I did, so I'm going to change this just a little bit. And go ahead and make this, instead of HO on the bottom, go ahead and make this low. And then this can be low, low, and low. So high being the higher function, low being the lower function in position, not necessarily in value. Okay, so if I want to think about this, and I'm doing bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared, this also becomes low d high minus high d low over low, or over low squared. That d representing taking the derivative. Those of you in my classroom, you'll see the 7 dwarves. This is them singing this quotient rule. Low d high minus high d low over low. Now, you do need to commit this to memory, so whether or not you want to think about it in bottom and top or high and low, that's up to you, but make sure you are getting that in your head in some form or another, so you are ready for that AP test. All right, so you have 3 examples that deal with either polynomial or trig functions. Examples 1, 2, 3. So this is one of those things we just need to practice. A little hint, if you can start this part correctly with bottom or with low, you will be more successful. A lot of times what people end up messing up is they try to start with the top function, and we just don't want to do that. So low d high minus high d low over low. And I want you to try these 3 problems. You do not have to simplify your answers. Leave them as messy quotients, and that's fine. Go ahead and try these 3, and once you are done, you can unpause your video and check your answers. So go ahead and pause now. All right, so hopefully you paused your video, and again, I did some color coding. For me, green is going to be my bottom function, and purple is going to be my top function. So I have low d high minus high d low over low squared, or low. Now, you can clean this up if you want to, but you're going to spend a lot of time trying to make sure your answers match my answers if you do too much algebra cleanup, because I'm going to leave most of my solutions just like this. Okay, but if you want to, you can go through and you can combine like terms and do a whole bunch of algebra. That's okay. Example 2, again, top function and bottom function. So low d high minus high d low over low or low squared. Something important to note is that this means the same thing as this. These are equivalent. That is not necessarily the same thing as that, because this could be taken this way, in which case the square is inside the cosine instead of outside, and then trouble happens. So you can write it this way with the 2 near the s, or you can write the whole thing squared. And your last one, low d high minus high d low over low or low squared. Now we're going to use this new rule to help us find 2 more trig derivatives that we can work with. So you already know how to find the derivative of sine and cosine in a previous lesson. And so we're going to now add to that finding the derivative of tangent. So again, finding the derivative, we're finding rates of change, that slope of the secant line becoming the tangent line. Don't forget that that's all what's happening here. These are just shortcuts for how to get there. So to find the derivative of tangent, I'm going to write it in a way that makes sense with functions that I already know information about when it comes to taking the derivative. So using the trig identity, sine of x over cosine of x, now I can apply my low d high rule with these 2 functions. So y prime is going to equal low d high minus high d low all over low, or low squared. So I just got done talking about how we don't clean up our answers in AP, but since we're trying to find a nice rule for taking the derivative of tangent, we are going to do a little bit of cleanup here. So I'm going to say this is y prime equals cosine squared x plus sine squared x all over cosine squared x. Now, we can't cancel these quite yet, right, unless we split this into two fractions. You can't just go like this and say it's sine squared. But what we can do is we can think about our identities. And we know that cosine squared plus sine squared from our trig days is equal to 1. And we have cosine squared left in the denominator. Well, using reciprocal identities, the reciprocal of cosine is going to be secant. So this means that the derivative of tangent is equal to the secant squared of x. This is a new trig rule that you should commit to your memory, something you are going to be responsible for. But like we just showed, it's not that hard to derive, so if you ever forget it, you can always go back and just do a little quotient rule. So I'm actually going to have you try that now with cotangent. I'm going to give you the hint that from our trig identities, cotangent is the cosine of x over the sine of x. See if you can come up with the derivative of cotangent using the quotient rule. Go ahead and pause now. All right, there's a lot of writing on this one, but hopefully you followed your low d high minus high d low. And at the end, we just need to take out this negative sign. So we end up with a -1. And then we have our dividing by sine squared. So using our reciprocal functions, we're going to end up with negative cosecant squared. So the derivative of cotangent is negative cosecant squared. The derivative of tangent, wherever I lost my page, was positive secant squared. All right, the last thing that we're going to do today in this video, it'll go pretty quick, I promise, is learning about something called higher order derivatives. So a higher order derivative is just a derivative of, well, a derivative. So we take the first derivative, that's going to tell us information about a function dealing with its slope. Then the second derivative deals with the slope of the slope. And the third derivative deals with the slope of the slope of the slope of the function. So we've got a lot of different things going on, but our rules are still the same. The only thing that gets a little tricky is just paying attention to notation. So we've seen y prime before, and we've seen f prime. We've also used Leibniz notation dy dx, which is the change in y over the change in x, or taking the derivative with respect to x of f of x. These ones we don't use all that much, but they're good to be aware of, I guess. If I take the second derivative, I notate that with y prime prime, or y double prime. I would also say f double prime of x. This one, I put these little 2's on here. It has to do with the way that we calculate the rates of change with respect to different variables. Please note, this is not squaring a derivative. That was a big problem in previous classes. Okay, this little 2 and this little 3 does not mean square or cube. It means take the second derivative or take the third derivative. So same thing here, we've got 3 primes, and a little 3, not cubing, but taking the derivative 3 times over. All right, so find the first 4 derivatives of f of x. Well, it just means I'm going to need the derivative 4 times over. So to note this, I'm going to say f prime of x is equal to 3 times 6 is 18, x squared minus 4x. The derivative of a constant is just 0. But now I want to find the first 4 derivatives. All right, well, here's the first one. That is a terrible one. My second one, then, I'm going to say f double prime of x is equal to 36x minus 4. My third derivative of x is then going to be 36. And my fourth derivative will just be 0. So what this tells us is that the slope of the slope of the slope of the slope of the function is 0. Is that really helpful for right now? No. But we will work eventually with what the first derivative does as far as a function is concerned versus the second derivative, and even the third derivative has a physics application that we will discuss briefly later. So now I want you to find g triple prime triple prime, third derivative, at x equals 1. The third derivative, plug in 1 with your video paused, and then check your answer once you're done. Pause now. All right, so we get to our third derivative in this line, and then we want to evaluate that third derivative at x equals 1. So we should get g triple prime of 1 is equal to 18. All right, find the fourth derivative. This is our last example. Now, this is written as a quotient, which means I could do low d high minus high d low over low low, because I just learned that rule, and it's a really cool rule, and it has a fun little song to sing with it. But think about how much algebra I would have to clean up to then be able to take the next derivative. And then I'd have to clean up that quotient to take the derivative again, and then even a fourth time. So there's got to be a more efficient way to do this rather than using the quotient rule. And our way to be more efficient is to let algebra help us first. So I can rewrite this as x to the negative second, because then that negative sign just moves this exponent up, right? So now when I start to find my derivatives, this isn't so bad. Power rule. Do it again. Do it again. I feel like the hyenas in Lion King saying Mufasa. Do it again. If you don't know that reference, you should watch the movie. It's a great one. And we end up here. Now, we've got all these y4 tick marks. Some people would say, maybe I should just write that instead. But to me, y to the fourth looks like you're taking y to the fourth power. So you want to stay away from that. If you want to, you could use Roman numerals. That helps a little bit. But even that can get messy. A better option would be just to, from the beginning, replace your y with f of x. So then, when you start doing the calculus part, right, this is the first time we've actually done calculus, you can label these, and then when you get to here, you can actually write the fourth derivative of x. This is your final answer. You can leave it like that if you want, or you could write 120 over x to the sixth. So, quotient rule, low d high minus high d low over low low. Higher order derivatives, you're just taking derivatives of derivatives, which will have meaning for us later. And this does not mean square the derivative. It means take a second derivative. That's it.